Salutations, mini mathematicians! So happy that you could join us for our first lesson. That is remote learning. So let's get started. If you're still keeping your notebook, I want to continue showing you a lesson purpose. So we're going to be doing 6.2e lesson, creating cubes and nth roots. It's a printout. Maybe you're doing this on a write-on touch screen. Maybe you're just looking at it on the screen and doing it on a separate piece of paper. All is great. Our purpose today is we're going to connect cube roots and cubing to the third power and taking the third root to side lengths and volumes of cubes, because cubes are three-dimensionals. And then we're going to also apply rules of simplifying radicals to cube and nth roots. So let's get started. So taking a look, 6.2e, creating cube and nth roots. I have my calculator just in case. We're going to be filling this in. So find the volume of the cube. Describe the methods you are using. So there's a couple different ways we could find the volume of this cube. Remember how in previous module, we talked about the volume of any prism, and a cube is a prism, as being the area of the base that we used as little, or capital B, times the height of the solid. So if we take a look at this base is a square, so you notice that both the sides are going to be the same, 3 and 3. So we can say that the area of this base is a 3 by 3, which is 9, and the height of our figure is also 3. And 9 times 3 is 27, so this is 27 units cubed, because it's a volume. We can also think about this because all the dimensions are the same, and the area of the base is 3 times 3, or 3 squared, times the height, which is also 3. We can think about this as using our exponent rules. 3 to the second times 3 to the first is 3 to the third. 3 times 3 times 3, which is going to get us, again, you're right, 27 units cubed. So those are some different methods we can do. And notice, since 3 is the side, we can say that the volume of any cube, draw a quick little cube here, 2 squares, and then connect them. The volume of any cube is going to be side length cubed. And sometimes my S's might look like 5, so I sometimes use a cursive S to say side length cubed, and it's a little s because it's just a length. So let's take a look at our next table. It says complete the table below for the given perfect cubes. Just like there's perfect squares, there's perfect cubes. So this is going to be our side length, this is going to be our dimensions, this is going to be the volume in exponential notation, so using an exponent, and then this is going to be the volume of our cube simplified. So let's take a look at our first one. Let's see, if we have a side length of 2 units, and sometimes if you wanted to draw a quick little picture, that might be helpful for you. 2 by 2 by 2. The dimensions are going to be 2 by 2 by 2. And the volume of that cube means it's 2 cubed. And 2 cubed, 2 times 2 times 2, you got it, is 8. And we don't have to say what the units are in this table since we put it in the top here. It makes our table a little bit clearer. Okay, well, let's look at our next row. Our next row, our dimensions are 5 by 5 by 5, which means the side length of one edge of our cube is going to be 5. And we don't really need this word units there, but we can if we want. Since they did it there, we want to emulate their work as much as possible. So the volume in exponential form is going to be 5 to the third. And 5 times 5 times 5 is 125 cubic units. And I'm going to let you finish up C and D, and I will check back in with you in just a second. So go ahead and finish up C and D. Okay, so hopefully that was enough time to finish up. And if we take a look at C, since we have 8 cubed here, this is going to be 8 units. We're going to have an 8 by 8 by 8. And 8 cubed is 512. 512 units cubed. And then our last one, what if the side length is just S? And we kind of looked at this a little bit up here if we just had S. So if we just have S, the dimensions are going to be S by S by S. And that means exponentially S cubed. And there's nothing we can really do to simplify that. It's just the value of S, the length being cubed. Okay, so let's complete the following. If given the side length of the cube is X, what formula represents its volume V? So I want to know V is equal to, and what were we given? We were only given what about my cube? I'm only given that the side length of my cube is X. So if I take a look at this, to figure out the volume, if I know the side length, I'm going to do what to the side length? That's right, cube it. So X cubed. Good. If given the volume of the cube as V, what is the value of the side length? So I'm given V. I know that the entire volume of my cube is V, but I want to know what is the side length. So the side length is going to be equal to what? Side length is going to be equal to the cube root of the volume. And it's really important to have this little 3 here in this little foot of your radical symbol, because this is your index. It's going to tell you which root you're taking here. So if there's no number there, it's a square root, but since we have a 3 there, we know it's a cube root. Okay, cube and cube root are what kind of operations? Inverse operations. They undo each other, just like square and square roots, cube and cube roots. So let's see, true or false? Square root of 9 is equal to the cube root of 27. Explain your reasoning. Well, what is a square root of 9? Notice this is a square root because there's no index there. Square root of 9 is 3. What's a cube root of 27? Some number times itself 3 times is 27. Well, that's also 3. So when 3 equals 3, explain your reasoning. 2 factors of 3 is 9. 3 factors of 3 is 27. Awesome. So let's keep going. We're going to simplify the following cube roots, and we're not going to use a calculator for these, but we can use factor trees. So I'm going to help you out with the first one, and we're going to take some time and see if you can do the other ones, and we'll check back in. So let's take a look. Simplify the cube roots. The cube root of 64. Well, maybe you don't know what the cube root of 64 is off the top of your head. So you're thinking about 64, the cube root, and you think about, what factor goes into 64? Well, I know 8 does. I know 64 is 8 times 8. Okay, and then I know 8 is 4 times 2 and 4 times 2. And I can't stop here because I don't want pairs. I want triplets. I want 3 because this is a cube root. So I'm going to break up 4 and 2 and 2 and 4 into 2 and 2. So I have 2, 2, 2, 2, 2, and 2. So how many 2s is that? 1, 2, 3, 4, 5, 6. 6 2s. So this is the cube root of 2 to the third times 2 to the third you can think about. Because you want to pick triplets off your tree. You're taking 3s this time. And since cubing and cube rooting are inverse operations, I can pull out this 2, and I can pull out that 2. And we know that the cube root of 64 is 4. And again, maybe your factor tree looked a little different than mine. Maybe you first saw that it was 4 and 16, and then from 16 you break down to 4 and 4. And that's also a great thing to do. So maybe you saw 64 was 4 times 16, and then 16 is 4 and 4. So that's going to get your answer faster, but either way, you're going to get the same result. So let's take a look at the next one. Cube root of 27 over cube root of 125. Well, since this cube root belongs to the whole fraction, this is the cube root of 27 over the cube root of 125. And we saw above that the cube root of 27 is 3. And the cube root of 125 is 5. So this is equal to 3/5. Cool. Let's take a look at the next one. This is the cube root of a decimal. And before we said you can always turn decimal into a fraction. Don't get stuck on the decimals, turn them into fractions. So you could do that. The other thing you can think about is that this is one number times itself 3 times. And you have 3 decimal places, which means your answer only has 1 decimal place. And this is 27, and cube root of 27 is 3. So this is 0.3 being cube rooted. Cubing and cube roots are inverse operations. So this is just 3/10. Perfect. Go ahead and finish up D, E, and F, and I will pause the video, please, and thank you, and you can restart it again when you're done with F. Thank you. Okay, so let's see how we did on D, E, and F. So taking a look at D, you should have gotten 2 cube root 4. So when I look at the cube root of 32, remember cube and cube roots are inverse operations. So I went to 32 and I thought of 2 as a factor, and 2 times 16 is 32. 16 breaks into 8 and 2, and 8 breaks into 4 and 2. I'm going to stop there at 4 just because I have 3 factors of 2 right here. So I can think of the cube root 32 as being the cube root of 2 cubed times 4. Cubing and cube rooting are inverse operations, so the 2 gets pulled out, and the 4 has to stay on the inside. Remember, don't forget your index so I know it's a cube root. Otherwise, if you said this was a square root, you're not done simplifying yet. Let's take a look at E. 108. The first factor I thought of was 108 was 2 because it's even. But again, it makes an even number, so I'm like, ooh, let's use a bigger factor to be more efficient. 4. 4 times 27. And because we've been working so much with cube roots, I knew 27 was 3 cubed, so I broke it into 3 factors, 3 times 3 times 3. This can be a great slick trick for you to make your work more efficient. So the cube root of 108 is the cube root of 3 cubed times 4. Pull out the 3 because cubing and cube rooting are inverse operations. And we have 3 cube root 4 as our final answer in most simplified form. Now let's take a look at F. F, the final answer is 4x squared cube root 2. So let's take a look at this. I have the cube root of 128x to the 6, which is the cube root of 128 times the cube root of x to the 6, just like we'd break it up with square roots. Well, from there, remember that cube roots and cubing are inverse operations. So what we can think about is some amount cubed is x to the 6. X to the what power cubed gets you x to the 6. Remember your power of a power rule. Power of a power says you multiply these exponents. 2 times 3 is 6. Then cubing and cube roots are inverse operations, so this just ends up being x squared. Over here, 128, I thought of 2 and 64. 64 is 4 and 16, or maybe you already saw that it was 4 cubed. So I know 128 is 4 cubed times 2. Pull out the 4 because cubing and cube roots are inverse operations. And we have 4 and then the cube root of 2. Numbers on the outside get multiplied by the numbers on the outside. So 4x squared and then cube root 2. Excellent. What I'd like you to do is I'd like you to turn the page. I'd like you to work on 6, 7, 8, and 9. So pause the video and finish working through 6, 7, 8, and 9. And then we'll go over them together. Okay, let's see how we did. So find the side length of the cube. Remember, since we're given the volume, if you're given the volume and you want the side length is going to be the cube root of the volume. So here, I want to take the cube root of 1029. I'm going to make a factor tree. 1029. We're taking the cube root here. Well, let's see. Is 3 a factor? 1029. Well, 9 plus 1 is 10 plus 2 is 12. So I know 3 goes into 1029. 1029 divided by 3, using my calculator here, 343, since you've already done it. Then, I know 3 is a root. I'm hoping 3 works again. 4, 5, 6, 7, 8, 9, 10. Well, it won't work again. 343. What number goes into 343? Does 11 go into it? No. 3 doesn't work. 5 won't work. 6 won't work. How about 7? Will 7 work? 343. Oh, 49. Good. 7 and 49. 49 is 7 and 7. Remember, we want to pick up triples off of our tree. So we can say this is the cube root of 7 cubed times 3. Cubing and cube rooting are inverse operations. I'm going to pull out the 7. And the 3, don't forget your index, stays on the inside. And remember, since it's a side length, it needs units, and this is going to be meters. So there's my answer. Awesome. Does the cube root of 8 plus 64 equal 2 plus 4? Explain why or why not. So again, remember, because we have this addition here, it kind of ruins the whole simplifying. Because yes, 8 is 2 cubed, and yes, 64 is 4 cubed. However, because we have this addition here with order of operations, you would have to do the addition first. And 64 plus 8 is 72. Is a cube root of 72 6? No, it's definitely not. This is a false statement. Order of operations tells you to add first. Perfect. Wonderful. This big cube root kind of works as like a grouping symbol, so you have to do what's underneath first to simplify. Let's take a look at the next ones. Something that's really important to think about is thinking that, can my answer be a negative number? So remember, we cannot take the square root of a negative number, but can we take the cube root of a negative number? We can. Indeed, we can. So examine the cube roots of a negative value and complete the following. So does a cube root of negative 8 equal the square root of negative 8? Explain why or why not. No. The indexes, and that's the number here, the 3 and nothing there, meaning it's a 2, are different. The cube root of negative 8 is negative 2. Negative 2 times negative 2 times negative 2. Negative times a negative is a positive times another negative makes the whole value negative. And the square root of negative 8 is undefined. It's imaginary. Shh. It's undefined. It's not real. It's not a real number. So they're definitely not the same. And let's see, can we simplify the cube root of negative 216? Wait, the cube root of a negative? Oh, that's fine, because remember, a negative times a negative will be a positive times a negative again will get you a negative number. So let's see, 216. Well, maybe you've been working enough with these to already know what the cube root of 216 is, but maybe you don't. And if you don't, that's fine. You can always make a factor tree. And so 216, if I'm thinking about 216, I know that 4 will work. 4 and 54. And whenever I see the number 54, I think of 9, first of all. So 9 and 6. And then 9 is 3 and 3. And 6 is 3 and 2. And 4 is 2 and 2. So if I wanted to pick some triples, I'd have, oops, pen's a little dead. Get rid of it. Pick a different pen. Here's a triple. And here's another triple. So I know that this is definitely going to be negative. Pull out the negative. And you can think about that as, because negative 216, you can pull out that negative 1. You can think about negative 1 times negative 1 times negative 1. So you pull out the negative 1. Because you think about this as cube root of negative 1 cubed. And 2 cubed. And 3 cubed. So from there, since cubing and cube roots are inverse operations, negative 1 times 2 times 3 is negative 6. Or maybe already you remembered the perfect cube. 6 cubed is 216, so it's negative 6. Good job, you guys. So explain in words what happens when taking the cube root of a negative integer. When taking the cube root of a negative integer. Factor out negative 1. And the cube root of negative 1 is equal to negative 1. So that's what you have to remember. Because, for example, if I wanted the cube root of negative 8, I can think about it as the cube root of negative 1 times 8, which is the cube root of negative 1 cubed times 2 cubed, which is, since cubing and cube roots are inverse operations, negative 1 times 2, which is negative 2. Awesome. Let's take a look at 9, the last one you had to do before we went over these. Examine the 4th root. So the 4th root of a number, this is the 4th root. Notice the index is a 4. And same thing with square root, we looked for a pair of factors. Cube root, we looked for a triple of factors that are the same. And 4th root, you guessed it, we're going to look for 4 factors that are the same. So let's see. Does the cube root of 16 equal the 4th root of 16? No. Indexes are different. Cube root of 16 means a number multiplied by itself 3 times equals 16. And the 4th root of 16 equals a number multiplied by itself 4 times equal to 16. These cannot be the same number. Okay, explain in words how simplifying a whole number with a 4th root is different from simplifying a cube root. For a 4th root, you are looking for groups of 4 of the same factor. A cube root, you need groups of 3 of the same factor. And notice that these are whole numbers, so we don't have to talk about if the number was negative or not, because whole numbers are 0, 1, 2, 3, 4, 5, and so on. So that's kind of nice, we don't have to worry about it. Let's see, explain why the 4th root of negative 81 has no solution. No solution. Well, what does a 4th root mean? A 4th root means some number times itself 4 times is going to be equal to negative 81. Well, thinking about that, can any number multiplied by itself 4 times equal a negative? No, it can't. No number multiplied by itself an even number of times can be a negative value. And that's going to be really important to make sure you don't fall for any of those tricks. If I give you an even index and a negative number on the inside, there's no solution. Cool. Let's move on. Okay. Number 10, let's read the directions together. It says, in this module, you've seen square roots, cubic roots, and fourth roots. But it's important to note that roots come in all sizes. If n is a positive integer and a is a real number, any real number whose nth power equals a is called an nth root of a, denoted as nth root of a. So that's just saying that to undo this, a to the n to the nth power is going to be a. Yeah, same thing that we've been seeing, just putting a little abstract variable there. Okay, so simplify the following nth roots. Assume all variables represent positive numbers. So I'll do the first one with you, and then we're going to pause, and you can try and do B, C, and D on your own. So let's take a look. Fifth root of 96. Well, if I want the fifth root of 96, how many factors am I going to need that are the same? How many will be in my group? That's right, 5. So let's take a look. 96. The first number I think about going into 96 is, it's even, so 2. So 2 and 48. I'm going to stop at 2. And then 48, well, half of 48 is 24. And half of 24 is 12. And half of 12 is 6. And half of 6 is 3. So let's see, 1, 2, 3, 4, 5. Excellent. So here's a group of 5, and then don't forget about this 3. So this is the fifth root of 2 to the 5th times 3. Fifth power and fifth roots are inverse operations. So we pull out the 2, and the 3 has to stay inside. Be really careful when you draw your index. It looks like it belongs to the radical symbol and not as an exponent of the 2. We have to be really clear in our communication because those mean 2 different things. Okay, let's take a look. Oh, and don't forget D has a 6th power. So I just want to take a note real quick. Maybe you have room in your notes. Maybe you just want to write it on the side. If you have room, I didn't really have enough room. Remember that the square root of x is x to the 1/2 power, and that's why the square root of x squared, x to the 1/2, is x to the 1st. That's why they're inverse operations. And we can see the same thing with the cubed root of x is x to the 1/3 power. And that's why the cubed root of x cubed to the 1/3 power is x to the 1st. So again, you can kind of think about that slick trick. When we had square roots, we said if you had the square root of x to the 7th, you could have rewritten it because you want to divide the exponent by 2. We rewrote it as x to the 6th times x to the 1st. So then we could just divide the exponent here by 2, pull it out, x to the 3rd, square root x. We can use that same idea for when we're taking cube roots. If we had the cube root of x to the 12th, we can just divide the exponent by 3. So this is x to the 4th. We can also, if it's not a factor of 3, or sorry, a multiple of 3 here, x to, let's use the 13th. we can rewrite it as the cube root of x to the 12th times x to the first. And then divide this exponent by 3, x to the 4th, and then that cube root of x just has to stay inside. So you can think about that with higher roots. If you had the 4th root of x to the 21st, well, that's the 4th root of x to the, what's the biggest multiple of 4 that's less than 21? 20. So 4x to the 20th, x to the first. 20 divided by 4 is 5. Pull that on out. X to the 5th, 4th root x. And you could have an exponent on the inside. I notice most of my examples didn't. Just weird coincidence. So maybe I'll do another one. Maybe I'll have 4x to the 25th, 4th root. This would be x to the, oh, I guess I did it again. We'll make that a 26. X to the 20th. I'm sorry. X to the 24th. That's the biggest multiple of 4 without going over 26. X to the second, because 24 plus 2 is 26. So 24 divided by 4, your index is 6, so x to the 6th. And this x to the second has to just stay inside. So that'd be 4th root of x to the second. Awesome. So go ahead and finish working on B, C, and D, and we'll go over them in just a second. Go ahead, do your best. Okay, hopefully you had time to finish that up. Let's go over these. So 192, so I'm looking for the 6th root. So again, I'm going to be looking for 6 factors that are the same. So if I look at the 6th root of 192 using my factor tree, 192, well, 9, 10, 11, 12, 3 goes into this. So let's see, 192 divided by 3 gets me 64. Ooh, 64 is 8 and 8. Okay, and I know that 8 is 2 cubed. So again, maybe you broke it up to 4 and 2 and broke up 4 into 2 and 2, and that's how you got there. But I'm just saying, hey, I'm seeing these patterns. I'm going to use it. I'm going to use it to make my life more easy. Okay, so this is the 6th root of 2 to the 6 times, don't forget that 3, otherwise you wouldn't have 192. And 6th power and 6th root are inverse operations. Pull out the 2, the 3 stays on the inside. Great, great, awesome, awesome. Let's see how you did on C. So this is the 4th root of a to the 5th. So again, like we talked about on our separate piece of paper, a to the 5th is a times a times a times a times a. There's 5 factors, but 4th root only undoes 4th power. So what we need to look at here is the 4th root of a to the 4th, 1, 2, 3, 4, times a again. So here, 4th power and 4th root are inverse operations. So we're going to have a, and then this a has to stay inside, 4th root of a. Great work. If this was a negative inside, would there have been an answer? No, there wouldn't, because this is an even index. Perfect. So let's take a look at the next one. So this is probably one of the more challenging ones, but nothing you guys can't do. So let's take a look. This is the 6th root of x to the 8th and the 6th root of y to the 10th. Remember, 6th root only undoes 6th power. So how can I rewrite x to the 8th to have the power of x to the 6th? So that would be x to the 6th times x to the 2nd. Nice. And what about y to the 10th? Y to the 10th is y to the 6th times y to the 4th, because 6 plus 4 gets you 10. Remember, this is a product of powers. So then we can x to the 6th, divide that by 6, pull that out. 6th root x to the 2nd stays inside. Y to the 6th, 6th root, gets pulled on out. And y to the 4th has to stay inside. Number on the outside times numbers on the outside. Numbers on the inside times numbers on the inside. Simplify, simplify, simplify that radical. So your final answer here is x, y. 6th root, don't forget your index. Make it look like an index, not an exponent. X squared y to the fourth. Everything is in some beautiful alphabetical order, so I know that's my final answer. Okay, let's take a look. So here's a cute little table that's going to help us remember some of the items we looked at today. So some of the items we looked at today is A is a positive value, so the number on the inside is a positive number. And N is an even number, so that means your index here is even. So here we would have A being positive and N being even. So value of N to the A, and then what is an example of that? So taking a look here, what it asks for the value, they're asking not a numerical value, but they're asking, is it going to be positive or is it going to be negative? So taking a look here, if you have an even index and a positive number, okay, so give me an even number. 4, perfect, great number. Over a positive number, let's think. 16? Sure, 16. The 4 through to 16 is 2. So it's always going to end up being a positive solution. And it's going to end up being positive because since this is a positive number and this is an even, a positive number times itself 4 times will get you an even. Also a positive number. Over here, we're saying that N is an odd value. So your index is odd. And we still have A as a positive value. So let's think of an example for that. An odd number. First odd number that comes to my head is 3. So my index is going to be 3. And I just need a positive number on the inside. How about 8? Cube root of 8 is 2. So we're always going to end up with a positive solution here. That's because if you have a positive number and you multiply it by itself an odd number of times, this index could be 3, it could be 5, it could be 15. Any odd number of times, you're always still going to get a positive number. Okay, now let's get into the fun stuff. Here, your A value is a negative number. So if you had like negative 16, or your index is even, let's use 4. Does this have a solution? Is it always going to be positive? Is it always going to be negative? Or is there no solution? Here, there's going to be no solution. No number times itself, an even number of times, is ever going to be a negative number. So there's no solution there. So don't fall for those tricks if I put one on there. Let's take a look at this last situation. The last combination we could have is an odd index, such like 3, and a negative number on the inside. Let's use negative 8. Some number times itself an odd number of times can equal a negative number, because a negative times a negative is a positive, times a negative again is a negative. So this is negative 2. So this is always going to be a negative value. Awesome. So you might want to use this as kind of like a quick check on if you're getting your positives and negatives right, because you know those negatives can be a little tricky sometimes. Okay, so we have 12 through 25. We're going to be simplifying. We're assuming all the variables represent positive numbers. I'd like you to start working. You can work on the first half and then maybe check them with my video and then finish the second half. It'll probably take you about 10 to 15 minutes to finish this page, and we will go over the answers in just a second. So pause the video and we'll go over these answers in just a second. Okay. So let's go over some of these answers. 4th root of 81. So 4th root of 81. Well, when I see 81, I'm thinking about 9 and 9, which is 3 and 3 and 3 and 3. Maybe you already have that one memorized. So taking a look here, this is the 4th root of 3 to the 4th, which is 3. Excellent. Good job, mini mathematicians. So take a look at 13. 13, the 7th root of negative 1. Is this no solution, or is it going to be negative 1? Well, remember, this is an odd root of a negative number. If I multiplied a negative number by itself an odd number of times, I get a negative. So this is the 7th root of negative 1 to the 7th, which is negative 1. Don't forget to box or circle your answers so you can find your answers easier when you're checking your work. Okay, let's take a look at the next one. 4th root of 144. 144. Well, I think of 12 because 12 times 12 is 144 since we worked so much with our perfect squares. So we're looking at 144 with a factor tree, 12 and 12. But notice I want a 4th root. So I'm going to break this up into 2 and 6. I'm going to break this side up into 6 and 2. Stop at my 2's. And then 6 is 3 and 2. And this 6 is also 3 and 2. So I know this is the 4th root of, let's take a look, 1, 2, 3, 4. This is 4th root. And then, so 2 to the 4th. And I still have this 3 squared. So simplifying completely, 4th root to the 4th, pull out the 2. And this will end up being the 4th root of 3 squared, which is 9, because you want to simplify these completely. Okay, let's take a look at number 15. 5th root of negative 32. Whenever I see a really large index and the number underneath is even, I always go to 2 right away. So let's see, 32, negative 32, I guess we can say, negative 1 to the 5th power, because that will still be a negative number. And we can say that this is 2 and half of 32 is 16. And then 16 we know is 2 and 8. And 8 we know is 2 times 2 times 2. Good, 1, 2, 3, 4, 5. Or maybe you already had that memorized. Maybe you checked, so 2 times 2 times 2 times 2 times 2. Hey, 32. So here, 1, 2, 3, 4, 5. Always double check. And so this is the 5th root of negative 1 to the 5th and 2 to the 5th, or you can just think about it as negative 2 to the 5th power. And that means that this is negative 2. Good job, you guys. Let's move on to the next one. 16, 4th root of negative 625. 625, that's a big number. So let's jump right into it. Or don't. Really think about this. What is this problem saying? This problem is saying some number times itself 4 times is going to be a negative number. Possible? Impossible? Think about what this is before just jumping into your factor trees. I know how much you love factor trees, but this is no solution. Be smart. No solution. Perfect. Let's take a look at 17. 6th root of 7 over 6th root of 64. Wow, I could turn it into a decimal. I don't think it's going to really help me though. 6th root of 7 or 6th root of 64. Well, let's take a look at what 64 brings me. I know 64 is 8 and 8. Ooh, and I know 8 is 2 to the 3rd. 1, 2, 3, 4, 5, 6. So there's a group of 6. So this is 6th root 7 over 6th root 2 to the 6. Get me 6th root 7 all over 2. Remember, if you had a radical in your denominator, it's not completely simplified. You'd have to rationalize your denominator. So just be aware of that this is in simplest form. Take a look at the next one, number 18. Cube root of 81 over x to the 4th. Sorry, times x to the 4th. So cube root 81, cube root x to the 4th. We already did the 4th root of 81 up here, so we can kind of steal that factor tree if we wanted to and think about 81 as 4 factors of 3. But I only want 3 of them. So this is the cubed root of 3 to the 3rd times 3. Cubed root of, cube root only undoes cubing, but this is x to the 4th. So how should I rewrite x to the 4th? That's right. X to the third times X. And if you want to put X to the first just to help your brain out, do it. No problem there. So then cube and cube rooting are inverse operations. So I'm going to pull out a 3. That 3 stays inside. X cubed, 3 divided by 3 is 1. Pull out the X, and that X stays inside. Numbers on the outside times numbers on the outside. Numbers on the inside, numbers on the inside. Simplify, simplify, simplify that radical. Okay, so this is 3x cube root 3x. It's a deja vu problem. Excellent job, you guys. Okay, let's take a look at the next one. Ooh, I love it with the exponents. Okay, so remember, since this is a fourth root, all we have to do is take the exponent and divide by the root, which is 3. Or if you want to think about this as the fourth root of y to the third to the fourth, to see that exponents and roots cancel each other out, we get y to the third power. Cool, cool. Moving right along, moving right along. Okay, 10th root of -1. Think about it. Can we have the 10th root of -1? Is that a thing? Well, some number times itself an even number of times is going to be negative. Well, negative times a negative is a positive, and a positive times a positive is a positive. So this is impossible. This is no solution. If you get stuck, go back to that little table we just talked about on the previous page, and that will clear up your questions. Okay, 5th root of a to the 7th, 5th root of b to the 10th. 5th root a to the 7th, 5th root b to the 10th. Well, 5th root only undoes 5th power. So I have to rewrite this as 5th root a to the 5th times a to the 2nd. You got it. And 5th root, well, I don't really have to rewrite this one because 10 divided by 5 is 2. So the 5th root would be the 10th. I'll just pull it out. It becomes b to the 2nd. But if you want to see b to the 2nd to the 5th power, go ahead and do it. Okay, so 5th power a to the 5th, pull out the a. 5th root a to the 2nd stays on the inside. And here, 5th root and 5th power cancel out. This is b to the 2nd. Numbers on the outside times numbers on the outside. A, b to the 2nd, 5th root, make sure it looks like an index, a to the 2nd power. Alphabetical order, looking nice. Okay, 4 more. We've got this. Okay, 22. 6th root. Get a little closer. There you go. 6th root x to the 12th, n to the 18th. Well, I think we got this by now. That 12 divided by 6 is 2, so pull out x to the 12th, it becomes x to the 2nd. And 18 divided by 6 is 3, so pull out n to the 18th, and it's going to become n to the 3rd. Is that in alphabetical order? No, it's not. So we should probably write it as n to the 3rd, x to the 2nd. Just to communicate most clearly. Okay, 4th root 18n to the 4th power. Well, that's pretty simple because that exponent belongs to everything inside the parentheses because everything's being multiplied. This is a power of a product. This is just 18n. Oh, the more practice, the more easier this gets. So simple. Okay, big number. 5th root of 243, a to the 8th, b to the 15th. So let's see. 5th root, 243. 5th root, a to the 8th. 5th root, b to the 15th. Okay, luckily I have some room up here. I'm going to use 243. 4, 5, 6, 7, 8, 9. Okay, so I know 3 goes into 243. I'm going to grab my calculator here. 243 divided by 3, 81. Oh, nice. I know 81 is 9 times 9, and 9 is 3 times 3, so 81 is 3 times 3 times 3 times 3. And that is a group of 5. Okay, so this is fifth root of 3 to the fifth. Fifth root, a to the fifth times a to the third. And fifth root of b to the 15th, well, we know that's going to be fifth root of b to the third to the fifth power, because 3 times 5 is 15. Okay, so from here, pull out the 3. I can pull out a to the fifth, it becomes a. Pull out b to the third to the fifth, becomes b to the third. And what's left on the inside? The fifth root of a to the third. Don't forget your index. Make sure your index looks like an index and not an exponent. Okay, last problem. Here we go. Grab my pink marker. Cube root of, a negative, is that okay? Is that fine? Yes, it is, because we are taking an odd root of a negative number, and a negative times a negative times a negative, an odd number of times will still get you a negative. Okay, so let's see. Cube root of negative 125. Oops. Cube root of x to the 6th and cube root of y to the 8th. Well, maybe you remember that 5 times 5 times 5, or 5 cubed, is 125. So you can also think about this as cube root of negative 1 cubed times 5 cubed. Cube root x to the 2nd to the 3rd. Cube root y to the, okay, what's the biggest multiple of 3 that's still less than 8? Or you could always think about y to the 3rd. Well, I can do another y to the 3rd, 6, and then y to the 2nd. You can think about it that way if you wanted to. So from here, cube root of negative 1 to the 3rd, pull out the negative 1. Cube root 5 to the 3rd, pull out the 5. All together, that's negative 5. Pull out the x squared. Cube and cube root are inverse operations. Pull out y to the cube, pull out y to the cube. They each become y. Y times y is y squared. And then what's left on the inside? I pulled everything out here. I pulled everything out here. Oh, y squared. So there is your final answer. Okay, so you have the homework for this lesson to do this week. I wish you the best of luck. If you have questions, please feel free to email me. Don't forget to take a break to breathe. If it's still raining and you go outside, don't forget to change your socks. And you're doing the best you can, and that's all we can ask of you. So thank you so much. Do your very best and be nice to everyone. Ta-ta, toodaloo. See you later.